Okay, now let's see what is the different components which is there in a medical instrumentation system. That is a continuation of last class. So the first it will starts with the measurement, and then we have a option of using sensor and transducer based on the which type of biomedical signals we are measuring, and then we have a signal conditioning, and then we have the output display, and last one we have accessory auxiliary component. Okay, so first we will start with measurement. So we know what is meant by measurement. That is nothing but is a physical quantity or the property or the condition what we would like to measure. That is nothing but is the measurement. Okay, so here the thing is we have to be look into carefully is that what is the accessibility of this measurement is very much important. The thing is here, whatever measurement we are measuring, whether we are having some direct contact or just we are measuring over the surface of the body, or in presence of some radiation or some external disturbance we are measuring, or in form of any samples which is required to have a to measure that particular measurement. So based on this, the accessibility of that particular measurement it's get vary. Okay, so as I said, that's based on the accessibility. We have four things: internal on the body surface, or emanent from the body, or derived from the tissue sample. So this accessibility will vary from the measurement to measurement what we would like to measure. Okay. Based on that, the components followed components will also get vary to get accurate output. So what could be the measurement we will measure, especially in the biomedical that is biomedical signals, that is here in the sense it is a biopotential, pressure, flow, dimension. So this is mainly important if you want to have visualization in the form of image, or the displacement. It covers the velocity, acceleration and force, and the impedance. The impedance is nothing but is a resistance. Here resistance means it's full and full. Here we were focusing only on the skin, and then temperature, and last one we have the chemical concentration. So these are the thing we will consider as a measurements. From this measurements we will have some valuable information about what we are like to assess, like organs or system and so on. Okay, so this measurement, as I said, it may be some it represents some specific organ or some anatomical structure. Okay, so as I said before, the biomedical signals, if you want to extract or capture, the two things is very important. One is transducer, another one is sensor. So transducer is nothing but is a device which converts the energy from one form to another. For example, if you are measuring some mechanical energy, then it will get converted to electrical energy. Or if you are measuring the electrical energy, you need to convert it mechanical energy, then you can use for a transducer. Okay, so one such example for this transducer is physiological crystal. Okay, second one is the sensor. The sensor again, it's a component. It will have the sensing properties. It will sense what is the physical measurement, and it gives its equally electrical output. So it gives the thing is main difference between transducer and sensor is the sensor will give output only in the electrical form. It will not give output in the any other form, whereas the transducer is a device. It gives the output in any form what we like to have. That is, it can have the conversion process that one form of energy into the another. So transducer which have the two functioning, one is sensing plus another one is conversion, whereas the sensor will have only one properties, that is the sensing. It gives the output only in a electrical form, whereas it gives the output in any form as per our wish. Okay, so the sensor should be non-invasive or minimally invasive. So it is very much important when you are designing part. So invasive means then we have to do so many ethical clearance, and it may not also comfort for the person to have this type of placing the sensor. Okay, if it is invasive, so highly recommended to have sensing is only sensor is either it could be non-invasive or minimally invasive. The second part of component is signal conditioning. It's very very important. Okay, so whatever you are getting as a output, from the sensor or transducer. It's anyway it's going to be the electrical signal or some other energy. But the thing is here, it is not in up to the mark to process further in a followed electronic device. So it has to be conditioned in such a way to be easily processed in next stage or next process. So one such a block is nothing but signal conditioning block. Here we will conditioning the signal to proper form so that it can be easily understandable by the machine, and also it is easy for the machine to process further. Okay, so what kind of conditioning we will do here in the signal conditioning process? In the sense, one is amplifying process, or if you, because the output, whatever output you are getting from the sensor transducer, which is weak in amplitude, okay, that is a weak in strength, you have to strengthen that signal to some up to the mark. For example, if you are giving output in millivolt, the upcoming, the followed by electronic device access will not accept that voltage level, so it cannot be processed easily. So what we have to do in the sense, we have to strengthen that electrical signal in such a way the upcoming device will have some limit range, right? So it should fall within that limit range to be accepted by that following devices. So for that we have to amplify to strengthen the signal. And also here we are recording the data in real samples, that is live samples, live human body. So there is a tendency to have so many noise in acquiring signals. So we don't have only the raw data, we will also have some noise which is present in the raw data. So to filter that pure signal from this noise, and we have to do some filtering process, right? And also next is impedance matching, because each and every device, it has its own impedance, that is input impedance and output impedance. Everything has to be matched so that the data without any distortion, that is 75 percentage, at least 70 to 80 percentage of pure signal will transmit from one block to another block. So that the impedance matching is again is very much important as far as signal conditioning block. Okay, so this is what the signal conditioning. And then output display is very much important, because whatever we are doing, anyway we are going to have some representation in the form of graph or image and so on, so that we will have some conclusion, we will have some inference what we are trying to do, what it like to say, like that. So the output display, again it take many forms: the numerical display, graphical, discrete or continuous form, or permanent or temporary type, or visual or hearing. Okay, so these are the different forms of output we can have in designing. Okay, so next is auxiliary components. The auxiliary components is it's something, it's not necessary, but the presence of this component is very much important. It will have additional features to support the accuracy of that designing of some device. Okay, such auxiliary components here we have listed out as calibration signal. As I said, since it is a biomedical device, it is very important in calibration part, because the accuracy and precision is very important, since it is giving it showing the result of our human functioning part. Based on that treatment will be provided. So if the slight variation, the slight changes in that result, it will going to affect the overall treatment, or it is going to ruin the life of the people. So the calibration is very important. So that is going to be one of the auxiliary components. And second one is control and feedback part. So again here, most of this devices we are using as a real-time data, real-time recording or monitoring device. So in such a case, if we have automated customized thing, we can have this block, that is control and feedback block. So this responsible what is the response of this particular block is, it will continuously adjusting the input based on the output which we are getting, until it meets the expected output. Okay, so until then it will continuously modifying the input based on the output. This is very much important. And we will have the other option of storage and transmission, that is also again going to be the auxiliary components. Okay, so as I said, the control and feedback block maybe can be operated as a automatic or manual. Uh, and the other auxiliary is storage and transmission. If you want to transmit the data from one place to another place, we can also transmit, so that the remote monitoring is it's making possible to some nurse station or medical centers or medical data or you want to do some process in future purpose. So like that we can have for that features we can have this auxiliary components like storage and transmission. Yes, thank you.